locus of a point. Locus means it's a path when a point moves. Suppose this is the coordinate system. This is the coordinate system. This is x-axis. Cartesian system we are considering. Y-axis. So this is a point, say P. So P is moving and it follows some law. Suppose distance of P from a fixed point, say this is the point, say A. So P is a moving point and A is fixed point. Suppose we are considering this is AP. If P is here, then this is say A unit. If P is here, then this is also A unit. If P is here, this is also A unit. So P is moving and it traces this path. So this path we say this is this path, the path of P. We say this is a locus. Path of P is a locus. If it follows this rule, then we say P moves such that distance from the fixed point A is constant and it is A. So P is variable point, so we can say P, its coordinate is xy. So xy varies, variable. So A is fixed. Suppose distance, suppose coordinate of A is say alpha beta. Then what is say x minus alpha whole square, distance between P and A, it is x minus alpha whole square plus y minus beta whole square root over. So this is equal to A. And this is the equation of the locus, equation of the path. So this is locus. So if we have to find locus of a point, P which moves such that distance from the fixed point A is A, then fixed point is say A alpha beta, then this is the locus. And if we simplify this, we have the general equation of a circle, and that is so this is the locus. Then after locus, what we should say, equation of straight line. Then we will come to equation of straight line. So the general equation of of first degree in xy, first degree in x and y, in xy means this is the two-dimensional coordinate, it is variable. So general equation of first degree in xy is ax, a is constant, plus by plus c is equal to 0. Now xy is the moving point, and when we say about about say straight line. So this is system. So this is the line we are drawing. This is a line L. Then what is say this L makes some angle theta here. So this theta we say tan theta. We find this tangent of this angle theta, and this tan theta we say gradient of L. Now this is the point, this is angle theta. Then this tan theta is given by this say y. It is if it is say C, this point is say 0 C. This point is say xy. This is xy, or then xy is the moving point. This is 0 C, and we have y minus C by x minus 0. So y minus C by x minus 0, and this is the tangent of the angle. This is tan of theta. Means what? This xy follows this rule. So C is 0 C is a point on the line, and this point is what? It is x coordinate is 0, or we say this point is the point of intersection of the line and the y-axis. So it is the point, so its x coordinate is 0. X coordinate is 0 and y coordinate is C. Means what? It is the distance between the origin and the point of intersection. It is C. We say this is the y-intercept. C we say C is y-intercept, or intercept on y-axis, y-intercept of the line, intercept. And this L follows this rule, and simplifying this, what we have, y is equal to, and this tan theta is standard notation for straight line is m. M is the gradient of the line. So y is equal to mx plus c. So y is equal to mx plus c. So this is the equation of the straight line, or locus of the point which moves such that its gradient is m and y-intercept is c. And this y is equal to mx plus c. If we say this ax plus by plus c equal to 0, then what we can write, by, say y we keep on left hand side, so by is equal to minus ax minus c, then y is equal to minus a by b x minus c by b. And comparing to this, we say this minus a by b is m and minus c by b is c. So minus c by b is y-intercept and minus a by b is the gradient. So what we are having, the general equation of first degree in x and y represents a straight line, and its gradient is minus a by b, and intercept on y-axis it is minus c by b. And this y is equal to mx plus c, if it is in this form, or this one, suppose we are writing this equation, say 2x plus 3y plus 5. So this is the equation in first degree in x and y. So we write y as minus 2 by 3 x minus 5 by 3. So gradient is minus 2 by, so it is of the form y is equal to mx plus c, and it is the gradient form the line. So if we are given this equation, we say this minus 2 by 3 is the gradient and minus 5 by 3 is the y-intercept. So this is the straight line, equation of straight line, and this is y is equal to mx plus c. So there are different forms of straight lines: intercept form, normal form, etc. So y-intercept is the point of y-intercept of a line is what? It is the distance in between origin and the point of intersection of the line with y-axis. And in a similar way, x-intercept of the line on is the point of intersection of the line and the x-axis, distance between that point and the origin. We say it is the x-intercept. And normal form is what? So when we imagine a straight line, then there is a coordinate system, and this is a line, this is a straight line, or another line we are taking, say this is a straight line, say this is a line. So this is say L1, this is say L2. So what we are having, this point, this is the x-intercept of L2, this is x-intercept, y-intercept of L2, and for L1, this is y-intercept of L1, and this is x-intercept of L1. So if we know this as, so x-intercept, if it is x-intercept is a0, then is y coordinate is 0, then if y-intercept is b, then 0b is a point on the line. So we have, if we know x-intercept and y-intercept, then we have 2 points on the line we can know about this. Now equation passing through 2 given points. So equation of a line passing through 2 given points, and given points are say they are say x1 y1 and x2 y2. So x1 y1, suppose this is the point x1 and this is the point x2 y2. So this is the point say b, and this is the point say a. We are saying this is a and this is b. So suppose a, b are points on a line. So then what we have, this, if we complete this triangle, this is parallel to x-axis, this is parallel to y-axis. So suppose this is m, then am, bm. So this angle is theta, this angle is theta. Same angle means what? Tan theta is a gradient. And what is tan theta? Tan theta is bm by am. Again, if P is a variable point here, suppose this is P is a variable point. Variable point means its coordinate is xy. Then in a similar way, if it is n, if it is P, it is perpendicular, it is say n, then what we have, tan theta is again it is Pn by An, Pn by Bm by Pn by An. So from this equation, what you can write, so Bm by Am is y2 minus y1 by x2 minus x1, and Pn by, so P is having coordinate xy. So Pn is y minus y1 and An is x minus x1. So we have this equation, because y1, x1, x2, y2, these are known value, and we can have an equation, first degree equation in x and y. Suppose, for example, suppose we are writing, say A is say 1 1 and B is say 2 3. So if we write x1 y1 as 1 1 1 and x2 y2 as 2 3, so what we have, so it is 3 minus 1 by 2 minus 1 is equal to y minus 1 by x minus 1. And after simplification, what we have, 3 minus 1 by 2 minus 1, it is 2, so it is twice 2 into x minus 1 equal to y minus 1. So we have a first degree equation in x and y. So it is twice x minus y minus 2 plus 1, so it is minus 1 is equal to 0. So this is equation of straight line. So what we are having, for gradient form of a line, we have to know gradient m and y-intercept c. Then equation passing through two given points, we need to know x1 y1 and x2 y2. So these are the way to form the equation of a straight line, and all these are we are doing using the rules, or these are all locus of a certain point, following following some given rules. They say in the gradient form, it is moving as making a constant angle theta and having intercept c, or when for the second, the equation passing through two given points. So that is the rule, it passes through two given points. So what we are having, when we are given two points a and b, then it always we can find equation of a straight line. So equation of a straight line means what? So this is a straight line, and every point, so suppose this equation is say twice x that we have given earlier, twice x minus y minus 1 is equal to, suppose this is the equation, then any point here will satisfy this equation. Suppose x is equal to 6. So if x equal to 6, then from this equation we can find y coordinate. So it is 6 into 2, 12 minus y minus 1. So y must be equal to, so y, from this equation y should be 11. So what we are having, 6 11 is a point on the line. So means what, when two points are given, we will have a unique straight line. So in any 2 points are there, there is a unique line, there is a unique line. Only one equation we will have. So we are having Gaussian form, then equation passing through 2 given points, then intercept form of a line. Intercept form of a line is, if it is x-intercept is, say x-intercept is a, y-intercept is b, then what we are having, a0 and 0b are points on the line. So passing through a0 and 0b you can find easily. So it is y minus b by x minus 0 is equal to b minus 0 by 0 minus a. And after simplification, what we have, y minus b is equal to minus b by a x, or we can have ay minus ab, ay minus ab plus bx equal to 0, or if we divide by ab, we have x by a plus y by b is equal to 1. So this is the, so if a and b are intercepts on x-axis and y-axis respectively, we have this equation as x by a plus y by b is equal to 1. So this is the intercept form of a line. And another form is there, it is a normal form. Normal form of a line is, this is a normal form, it is this is a line, then we draw perpendicular from origin. So we say this point is this as p, this is as p, and this angle is alpha, and we have our equation is then, so p and alpha are known, so our equation is then x cos alpha plus y sin alpha is equal to p. So this is the normal form, this is the normal form of a line, of a straight line. So this x cos alpha plus y sin alpha equal to p. If we know this equation, if we know this form, then what do you say? This p is the perpendicular distance of the line from the origin. We know this value, distance of the line from the origin. So our equation is given, say ax plus by plus c equal to 0. Then what we have, it's Gaussian form we have got, then normal form also, to the intercept form is also, it is the way ax plus by equal to minus c, then x by a, so we write this is minus c by a plus y by minus c by b, b is equal to 1. So this is x-intercept, this is y-intercept. And for normal form, what we need to do, it is ax plus by plus c, so we need to write a by, we need to write what, we need to write a by root over a square plus b square x plus b by root over a square plus b square y is equal to minus c by root over a square plus b square. Then this is cos alpha, this is sin alpha, and this is p. So when we have to find distance of a line ax plus by plus c from origin, then our distance is this one, minus c by s root over a square plus b square. So this is the way to find different form of equation of a straight line. And when we know this normal form, what we have, so this is a line, this is a line, this is a point here, say it is say r say alpha beta, r alpha beta. Then distance of r to the line, so this distance d, so d is given by a alpha plus b beta plus c. If the equation is ax plus by plus c, then this is root over a square plus b square. So this is equal to d. So distance of this is distance of, it is distance of r to the line ax plus by plus c equal to 0. And another thing is there, angle between two lines. So angle between two lines, angle between two lines we write in the gradient form. So y is equal to m1x plus c1, and another line is y is equal to m2x plus c2. In this case we have theta is equal to theta 2 minus theta 1, where tan theta, so when m1 is equal to tan theta 1 and is gradient of the first line, and m2 is equal to tan theta 2, gradient of the second line. So we know the formula tan of theta 1 minus theta 2, theta 1 minus theta 2. We can find this because we know tan theta 1 and tan theta 2. So this theta 1 minus theta 2 is, or theta 2 minus theta 1, this is theta. We can find the value. This is angle between two lines. Now two lines, two straight lines, they are two lines are parallel. Two lines are parallel when theta 1 equal to theta 2. So this is a line L1, this is a line L2, L1, L2. So this is theta, same angle, so they are parallel. So when m1 equal to m2, it is condition of parallelism. So L1 is parallel to L2, parallel to L2, implies m1, implies and implied by m1 equal to m2. So what we are having, if m1 equal to m2, then two lines are parallel, or if two lines are parallel, then m1 equal to m2. And for perpendicularity, our angle should be, say this is L3, this is say L3. L3 means what? This angle must be equal to 90 degree, pi by 2. Means what? Distance between, angle between L1 and L3 should be equal to 90 degree. Means what? This theta should be equal to 90 degree. So what we need, tan theta 1, so tan theta, tan of theta, so theta should be equal to pi by 2, tan of pi by 2. So then if we use the formula tan of theta 2 minus theta 1, then it is tan of theta 2 minus tan of theta 1 divided by, this is the formula for this is 1 plus tan theta 1 tan theta 2. So in place of tan theta 1 we write m1, then it is m2, so it is m2 minus m1 is 1 plus m1 m2. So tan of pi by 2, it is infinity. Infinity means denominator is 0. So this implies 1 plus m1 m2 is equal to 0. So what we are having, this implies product of their gradient is minus 1. So m1 m2 is equal to minus 1. From this also we have m1 equal to m2. So if theta equal to 0, parallel means theta equal to 0, angle between two lines is 0. So tan 0 means this is 0. So tan theta 2 minus tan theta 1 equal to 0. So m2 minus m1 equal to 0 means m1 equal to m2. So from this ratio what we have, if theta is 0 then m1 equal to m2, and if theta is pi by 2 then this is equal to minus 1. So once we have angle gradient of the line L1, we can find gradient of L3 because of this relation. So once we know m1, then we can find m2, the gradient of the line perpendicular to the given line. So this is the things we need to know, and we'll see now the examples. So find locus of a point moving at a constant distance 3 from 4 1. So constant distance 3 from 4 1. So what we do, this is P is xy, P is xy, then A is 4 1 and AP is equal to 3. So AP is equal to 3, and distance formula is x minus 4 whole square, x minus 4 whole square plus y minus 1, y minus 1 whole square. Now we simplify it. This implies 9 is equal to, we are taking the square, so to remove this, so it is x square minus 8x plus 16 plus y square minus twice y plus 1, and we can simplify the constant. So it is x square plus y square minus 8x minus twice y plus 17 minus 9, it is 8 plus 8 equal to 0. Second is this, and third is equidistant from minus 4, minus 5 and 3 0. So equidistant point means two points A and B are given. So number 3 say, so A is minus 4 minus 5 and B is 3 0, and P is the current point, moving point. So AP is equal to BP. So by distance formula we find implies root over x minus minus plus, so x plus 4 whole square plus y plus 5 whole square, this is equal to root over x minus 3 whole square plus y minus 0 whole square, and we remove the square root. What we are having now, this implies x square plus y square plus 8x plus 16 plus 10y plus 25 is equal to, right hand side is x square plus y square minus 6x plus 9. And after simplification, x square y square goes, where we are having 14x plus 10y, then plus 7 plus 25 is 32, plus 32 equal to 0. This implies 7x plus 5y plus 32 equal to 0. So this is equation of a straight line, first degree equation in x and y. Then locus of moving point, it moves such that the distance from this and this 3 times distance from this. So what we do, so AP, A is this, B is this, so AP is 3 times, so AP is equal to 3 into BP. So in place of writing this AP equal to BP, we write AP equal to 3 BP. So this is the way to do this. Find the locus of moving point. Distance from this is equal to distance from y-axis. So what is distance of a point from y-axis? Is distance of this to so distance of a distance of P from y-axis. So when we write the coordinates, so this is P. If its coordinate is xy, then this is x, this is x, this is y. So distance of the point from x-axis is y, and distance of point from y-axis is x. So in this way, so moving point, P is the moving point, then its distance from y-axis, it is x. So we need to write distance between P and A is equal to x. Then find equation the line which makes angle minus 45 degree with x-axis and has y-intercept 1. So C is 1 here and M is minus 45 degree, and so the line is like this. This is x-axis, y-axis, y-intercept is 1, this is the point 0 1, angle is minus 45 degree, so it makes angle, this angle is minus 45 degree, so M is here is 10 of minus 45 degree is minus 1, C is equal to 1, so y is equal to minus x plus c. So this is the equation of the line, gradient from the line. Similarly, having gradient minus 1 passing through 4 1. So this equation, how we'll do it? Passing through the point. So gradient is given and another point is given. So gradient is minus 1. So if it passes through 4 1, means x1 y1 is given. So this is the line, gradient is minus 1, so it makes angle. So 4 1 is a point, 4 1, so this is the point, say 4 1, and gradient is minus 1, so this is minus 45 degree. So what we have, current point is xy, so y minus 1 by x minus 4. It is gradient of the line which passes through 4 1, and it is given as minus 1. So we then it is we now simplify this. So y minus 1 is equal to minus x plus 4. So this implies x plus y equal to 5. Then find equation the line passing through this and this. So this is y2 minus y1 by x2 minus x1, it is number 7 is it is y minus 2 by x minus 4 is equal to 9 minus 2 by 0 minus 4. Then simplify it is, so gradient is 9 minus 2 by minus 4, it is minus 7 by 4. Then simplify it, so this y minus 2 into 4 is equal to x minus 4 into minus 7. And simplify it and we will have it. Then this is also like that. Then find the equation of the line passing through minus 1 1 and having gradient 3. It is like this. So y minus 1 by, so this one is passing through minus 1 1, so it is a line passing through a fixed point minus 1 1 and which satisfies different condition. So number 8, so minus 1 1 is the point, minus 1 1 is the point here, this is minus 1 1. So passing through, so number 1 is passing through this and having gradient 3. It is y minus 1 by x minus minus 1, it is x plus 1 is equal to 3. And it is y minus 1 is equal to tries x plus 3, or the general equation we write as tries x minus y plus 4 equal to 0. Then number 2 is having y intercept 2. So having y intercept 2 means 0 minus 2 is a point. So what we have, equation passes through minus 1 and the point 0 minus 2. So passing through two given points it is, so y minus 1 by x minus minus 1, it is x plus 1 is equal to say minus 2 minus 1 by 0 plus 1, so it is minus 3. Then simplify it, what we are having, it is y minus 1, so this implies y minus 1 is equal to minus tries x minus 3. So this implies tries x plus y, tries x plus 2 plus 2 is equal to 0. So for this one equation is tries x minus y plus 4 equal to 0. For 2 it is tries x plus y plus 2 equal to 0. Then number 3 we see passes through 3 4. So like this one, like number 2, our x 2 points are this, and here 2 points are minus 1 1. So number 3 we are writing here number 3. So y minus 1 by x minus minus 1 is equal to that next point is 3 4, so it is 4 minus 1, so 4 minus 1 by 3 minus minus 1. So it is 4 minus 1 is 3, 3 by 4 it is 3 by 4. So this is gradient actually, so gradient is 3 by 4. So after simplification what we have, 3x minus 4y 3 plus 3 and minus 4, so it is 7, I think 7 equal to 0. So this is 3x minus 4y plus 7 equal to 0. Then next, cut off equal distances from two axes. So cut off equal distances from two axes, this means this is the point, then equal distances from two axes. So this may be like this, or this may be like this. So we write a0. So intercepts are a, so a0 and 0a, equal intercept. So passing through a0 and 0a, so it is y minus a. Our intercept form is a by, so intercept form the equation is x intercept is y intercept is also a. So what we have, number 4, x by a plus y by a is equal to 1. So means what, x plus y equal to a. So these are the different equation passing through a given points. So x by a, y by a. Now our xy, and the point is minus 1 1. So minus 1 1, it is the line, this one. So minus 1 by a. So what we will have, either it is this line or it is this line, or it is this line. So a0 0a, so if it passes through this one, this one one, so x plus y is equal to so x plus y is equal to a. So x is minus 1, y is 1, so it is x is 1, y is minus 1, 1 minus 1 plus minus 1. So it is the point, this is the point minus 1 1. So if it is here, then this is a, then what we have, this is 45 degree, so a gradient is minus 45 degrees. So m is equal to minus 1. So m is equal to minus 1, and we have as y minus 1 by x plus 1 is equal to minus 1. Our equation is now y minus 1 is equal to x plus 1. This means it is x minus y is equal to 2. So this is the, and so we have a is equal to 2. So because it is in this quadrant, so a cannot be equal to, so they must be of opposite sign. So if one is a0, then other must be 0 minus a. So like that. And if it is through this point, then it will be 0. X equal intercept, it passes through 0, no solution. So this doesn't it doesn't have for this solution, so it passes through, it is 0. Either it is 0 intercept or it is this intercept. Then the equation the equation the straight line, write in gradient form, intercept form, perpendicular form. The length of perpendicular, so the length of perpendicular formula is given. So number 9 solution you can have, gradient form is y is equal to 6 by 8x plus 5 by 8. So this is the gradient form. Then intercept form. Intercept form is x 6x minus 8y. So constant term we take to right hand side. Then this implies x by minus 5 by 6 plus y by 5 by 8. We need this sign as plus, and this is also plus, so this is equal to 1. So what we have, x intercept is minus 5 by 6 and y intercept is 5 by 8. Then number 3 is perpendicular form. So for perpendicular form we need to divide by root over a square plus b square. A is 6 here and y is this minus 8, and right hand side should be constant. So what we have, 6 by root over 6 square plus 8 square x plus minus 8 by root over 6 square plus 8 square and y is equal to minus 5 by root over 6 square plus 8 square. So this is the normal form or perpendicular form. Then number 10, distance, length of the perpendicular. Length of the perpendicular formula is, this is 10. So it is a alpha plus b beta plus c divided by root over a square plus b square. So alpha is 2, beta is 1, so 1 is d is equal to 11 into 2 plus minus 7 into 1 minus 7 divided by root over 11 square plus 7 square. So this is equal to 22 minus 14. 22 minus 14 is 8, and it is root over 121 plus 49, it is 160, root over 160, 170, 170. So this is the, then for second one it is 0 0, so it is 0 0. So number 2 it is d is equal to 0 0 means it is only constant term will come, so it is minus 9 by root over 1 square plus 5 square, 25. Then number 3 is minus 1 1, so it is d is equal to 4 into minus 1 minus 3 into 1 minus 7 by root over 4 square plus 3 square, 4 square plus 3 square. So it is minus 4 minus 3 minus 14 equal to minus 14 by 5. So this is the formula for this. Then find point of intersection of pair of lines. So point of intersection of pair of lines, we need to solve it simultaneous. We have solved simultaneous linear equation. So in this way, then we have solved simultaneously linear equation. It is the, means what, there is only one point xy which satisfies both the equation. That is the point of intersection of the two lines. So number 11, 1, we solve it. So 6x plus 2y minus 1 equal to 0. Then 3x minus 5y plus 1 equal to 0. Then if we make it 6, then it is 6x minus 10y plus 2 equal to 0. Then this minus this gives us this is 2y 6x minus 6x is 0. Then 2y minus 10y is 12y. 12y minus 3 equal to 0 implies y is equal to 1 by 4. If y equal to 1 by 4, then we replace it here. If it is 1 by 4, then it is half. So half minus 1 is minus half. So half minus 1 is minus half. So 6x is equal to half, means x is equal to 1 by 12. So what we are having, this point is 1 by 12 comma 1 by 4. We can check it. 1 by here we put 1 by 12, it is half. Here we put 1 by 4, it is half. So half plus half is 1, so it is satisfied. And then if we put here 1 by 12, it is 3 by 12 is 1 by 4. 1 by 4, then it is minus 5 by 4. So 1 by 4 minus 5 by 4, it is minus 1. So minus 1 plus 1 is 0. So it is satisfied. In this way we find this these things. Then prove that the following lines are concurrent. So concurrent means we find point of intersection is of this point. If it satisfies this equation, then it is concurrent. So first find point of intersection of this. Say it is twice x plus 6y. So 12 1. I will try it. This is 12 1. It is twice x plus 6y. So if we multiply by 3, 3, or we multiply by 2, the second equation. So first one is twice x plus 6y plus 1 equal to 0. Then we multiply by 2, the second equation. It is 12x minus 6y minus 8 equal to 0. Then add it. This will go. Then what we have, 14x equal to 7. 14x equal to 7. And x equal to 2. X is equal to 2. So if x equal to 2 here, then it is 2 into 2, 4. 4 plus 1 is 5. Then y is equal to, x is equal to 2, means y is equal to minus 6 by 5. Minus 6 by 5. So point of intersection is of the first two line is 2, then minus 6 by 5. And let us see it will satisfy the third or not. So if in this equation we write x equal to 2, then it is 12 into 2 plus 21 into minus 6 by 5. I think minus 8. 12x minus 6y minus 8 is equal to 0. It is 14x minus 7 equal to 0, means x is, x equal to half. This is half, and y will be, x is half and y will be 2 into half, it is 1. 1 1 2. So y is equal to minus 1 by 6, not this one. So x is half and it is minus 1 by 6. Minus 1 by 6. Half plus 1 plus 1 2, minus 1 by 3, not half plus 1 half true, so minus 1 by 3. So half minus 1 by 3, then 12 into half plus 21 into minus 1 by 3 is equal to 6 minus 7 is equal to minus 1. So minus 1 plus 1 equal to 0. So what we are having, so point of intersection of these two lines, it is half minus 1 by 3, and this half minus 1 by 3 satisfies this equation. If we put x equal to half, y equal to minus 1 by 3, then we have this simplification is 0. So this is the way to prove the concurrency of the three lines, means they passes to the same point. Then angle between line, these are the m1 m2 we find. So m1 is 13.1, m1 is minus half, m2 is minus 6 by 5. Then theta is tan inverse of m1 minus m2, so it is minus half plus 6 by 5 divided by 1 minus m1 into m2, half into 6 by 5. So this is the value, it is 10, then it is 12 minus 5, it is 7, so this is 7 by 10, and this is 10 minus 6, it is 4, so it is 7 by 4. So this is the angle. Then number 14, find the equation of the line passing to the point of intersection of this and through the point 3, 4. So there is another thing is there, point of intersection of a line of two lines. So point of intersection of two lines, there is a general equation, which passes through point of intersection of two given lines. This is given as number 14. So equation to the line passing through point of intersection of two lines, means ax plus by plus c equal to 0 and a dash x plus b dash y plus c dash equal to 0 is, the equation is ax plus by plus c plus lambda, you write lambda into a dash x plus b dash y plus c dash equal to 0. So this is a formula. So our ax plus by plus c is this one, a dash x plus b dash y plus c dash is this one. So we write the general equation and then we put the point 3, 4 here, and we have the value lambda. So to do this problem, what we have, so in place of 14.1, how will you write it? How will you write it? Number 14. So equation, so it is twice x, so 1, it is the line is twice x minus thrice y plus 5 plus lambda into x plus twice y minus 3 equal to 0. So this is the general equation. This is say 1. Then 3 4 is the given point, lies on 1, implies 2 in place of x we write 3 minus 3 into 4 plus 5 plus lambda into x is 3, then 2 into 4 minus 3 equal to 0, and from this we have the value of lambda. So this implies 6 plus 5 11, 11 minus 12 is minus 1. So lambda is equal to, this is 3 minus 3, it is 0, it is 8. So it is 1 by 8. Lambda is equal to 1 by 8. Now we put the value of lambda here. Lambda 1 by 8. 3 4, it is correct. 2 into 3 is 6, 6 plus 5 11, 11 minus 12 it is 1, minus 1. Then it is 3 minus 3 it is 0, and it is 2 into 4 it is 8. So it is 1 by 8. It will be 1 by 8. Now we put 1 by 8 here and we'll have the equation. Let us find it. 1 by 8. So here we write lambda equal to 1 by 8. Lambda is 1 by 8. So in the equation 1 we write, so from 1 we have now 2 in twice x minus thrice y plus 5 plus 1 by 8 into x plus twice y minus 3 equal to 0. So coefficient of x is 2 plus 1 by 8 into x, plus coefficient of y is minus 3 plus 2 by 8 is 1 by 4 y, then plus 5 minus 3 by 8 is equal to 0. We simplify it now. It is 8 into 2 it is 16, 17x, so it is 17x. Then this 8 if it is 2 by 8, then it is minus 24, it is minus 22y, and 40 minus 3 it is 37, plus 37 equal to 0. So this is the equation. Let us see if 3 4 satisfies or not. So 3 into 3 into 17 it is 51, 51 minus 88 plus 37. So 51 plus 37 it is 88, and it is 88, so it is 0. So what we are doing, our general equation we write, it is lambda we write here, then because 3 4 is a point here, we write x equal to 3, y equal to 4, and then we find the value of lambda. Then we again put the value of lambda equal to 1 by 8 here and simplify it, and we have this equation, first degree equation in x and y, and it will give the value of this. Then concurrent compound points you can find, and find distance between the parallel lines. You can find the distances between the two parallel lines, then show that the following points are collinear. reflection on a point. So these are the different types of problems. To find distance between two parallel lines, what we do, it is, these are the parallel lines because m is same. Here m is 1, this here also m is 1, so they are parallel. So what we can do, any point on this, say a point on say 16 1, or we can write distance between parallel lines is d1 minus d2 modulus. So d1 is, so d1 any d1 is from origin, we say, so 1 by root over 3 square plus 3 square minus d2 is, this is minus 1 by root over this, and this is minus 5 by root over 1 square plus 1 square. Simplified. So this is equal to 3 root 2, it is minus 1 by 3 root 2 plus 5 by root 2. So it is, if it is 3, it is 15, then it is 15 minus 1, it is 14, so it is 14 by 3 root 2. So this is the distance. So we find our distance d1 from origin, the formula, here you see it is 5 by root over 5 square plus 14 square, here it is minus 3 by, so number 2 is, it is d1 is 5 by root over 5 square plus 4 square minus 3 by root over 10 square plus 8 square. So 10 square plus 8 square means 2 comes out, so it is 2 root over 5 square plus 4 square, so this is equal to 2 root over 5 square plus 4 square is 25 plus 16, it is 25 plus 16 42 41, then it is 10 minus 10 plus 3, so it is 13 by this. So these are the straight line, reflection of this. Then, and one thing we need to learn, it is general equation to the line parallel to ax plus by plus c equal to 0 is ax, so this coefficients will be same, this constant term will differ, equal to 0, this you should know. And another is general equation of the line to the line perpendicular to the given line ax plus by plus c equal to 0 is, we interchange the coefficient, so we write coefficient of y as coefficient of x, it is b x, then change the sign, then ay plus c dash is equal to 0. So this thing we need to know. So sometimes you have to find equation passing through the given point. And another thing is there, equation to the x-axis is y equal to 0. Equation to the y-axis is x equal to 0. Equation to the line parallel to x-axis at a distance x will be x is equal to parallel to x-axis. So x-axis parallel to x-axis. So this equation is y is equal to a, and this equation is x is equal to b. So this is all about straight line.